Hello everyone, good afternoon, dear author and invited guests. Welcome to Technical Session 5A. Myself, Karthik Bharadwaj, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 8th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2024, Pune, India. The 8th edition of the conference is being organized in a hybrid mode. The physical event is organized today in Pune, India, and the virtual event is being held through Zoom yesterday and today, that is tomorrow, that is 12th and 13th January 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given a time of 8 minutes to present their PPT and 2 minutes for the question answers. At 7 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected till the last. If you have any query or update, kindly write it to me in the chat box. Just before we get started, I would like to introduce you with today's session chair, Dr. Kirti Modi. Dr. Kirti Modi, professor and head of Sankal Chand Patel College of Engineering, Gandhinagar, India. Professor Kirti J. Modi is currently working as a professor and head at CE and IT department, IQAC coordinator at Sankal Chand Patel College of Engineering, and dean at Faculty of Computer Science, Sankal Chand Patel University. He has more than 20 years of teaching experience. He has published more than 25 research papers in the reputed international journal conference refer journals. He has served as a member of editorial board and program committees of international conferences and journal indexed in Web of Science and Scopus. Sir, we would like to listen the wisdom.
Yeah, hello. So, good noon to all,
Good morning,
and
sir.
I'm very much thankful to giving me this opportunity to join this conference as a session chair. And now I would like to invite the authors to share their session. Yeah, please.
Thank you, sir. Moving towards the first presentation, I would like to call Anand V for the paper title Anomaly Prediction in Real-Time Water Flow Data Machine Learning versus Statistical Models. Sir, you can proceed with your presentation.
Good afternoon, all.
Good
Like to
afternoon, sir.
yeah. I hope my screen is visible to you all.
Yes, sir, your screen is visible.
Thank you. I'm here to present anomaly prediction in real-time water flow data, a comparison between machine learning and statistical models. The agenda includes introduction. Basically, I would like to explain the problem statement, the background, the current status, and why this study. And there's a literature review done, and there is an objectives and methodology, design and implementation, and analysis and results, and conclusion and future stop. India, as of now, is being listed as 24th in extremely high water stressed countries by WRI's Aqueduct. The groundwater is extremely depreciating in most of the cities in India, and efficient water usage is being advised by government to most of the industries as of initial status, because industries are in the front runners. It's also organized, and they are also bound to financial risk, business continuity risk, and compliance risk. There's a lot of ESG norms coming into picture, and they are actually advised to reduce their water consumption up to 20% within 2 years. There's a true cost of concept water, where the at the exact cost of water they are procuring, it's not just about the water, the cost associated with procuring of water. It's also pumping, the energy associated with the pumping, the treatment cost, the chemical cost, and there's a lot of human involvement involved in it, but most of this is not accounted. So if you are saving at least 5 to 10% of water consumption in the facility, you are actually generating a lot of economic benefits as well. Currently, most of the industries are not equipped with efficient water monitoring and anomaly prediction methods. Right now, most of the methods are manual intensive, human intensive, and there is no proactive actions being taken to save water or to optimize the consumption. My research basically involves research helps on analyzing the historical water flow data and coming up with a best effective precise anomaly prediction method which will help the industries or which will help the user to take corrective action and optimize the water consumption. So the data acquired is from a dairy industry, which has an electromagnetic water flow meter connected with an IoT device. And the data is being labeled considering the site scenarios according to the dairy industry's production methods. And the data is acquired from a cleaning process pipeline where the vessels are cleaned after the milk production. And uh, there is a set of production data for each day, and accordingly the CIPs happens. So the labeling has been done according to the site scenarios, according to the flow rates, and this label data is being used to train the ML models as well as to compare the results of statistical models. The methodology includes implementing the analyzing the historical water flow data, labeling the data, and then implementing the statistical and machine learning models, which is being acquired, the data being acquired from the digital water flow meter, and comparing the performance of different models. Basically, we are considering precision recall and F1 score. And then the instant alerts will be generated to the ground workers based on the model implemented. And we have a efficient anomaly prediction system in the live data which is being posted in cloud. So the architecture basically is there is a sensor, there will be a data acquisition device, there is a cloud, and there is a mobile and web application. Coming to the cloud part, the data acquired from the IoT device will be going through certain processes where there is a the data is posted in Apache Storm, and then there are different balls where the bit array data is being converted into a JSON format. Then the initialization happens and time filter ball which removes the duplicates, and then the pre-processing ball where the anomaly prediction model will be implemented. And then it goes to the database, and the user has a mobile and web application where they can get insights and alerts based on the patterns observed. The the scenario which we have considered, the models which we have considered is mostly based on the latest data. So we have considered several moving average models, and we have considered KNN, isolation forest, SPM, and GMM. So why we have considered the moving average and the KNNs and isolation forest and SPM and GMM are because the industrial consumption pattern is very much dynamic. Uh, it is not a static. It is not a static operation. In several time series models, what happens is it depends upon the static data. It depends upon the stationary operation. So, but what happens with KNN and moving average methods are it considers the latest data, it considers the latest pattern of consumption, considers the latest behavior of the user, and it categorizes as anomaly, and it categorizes as the normal consumptions. So we have implemented multiple models, and we have come up with a conclusion that KNN has given the best results, where we are able to get a precision of 74%, recall of 86%, and an F1 score of 79%. And out of statistical models, we were able to get the best results from weighted moving average model, which assigns the which assigns the highest weight to the latest data acquired. And the precision recall and F1 score for weighted moving average was around 77%, recall was 10%, which was comparatively less, and F1 score was 17. So we were able to conclude that KNN gives the best results. KNN gives, compared to other models, the best results, which can be implemented in the industrial scenarios. We have to basically the what we have seen is the static thresholds, the traditional methods which being currently followed, which set the set threshold value, and it just classifies anomaly based on that static threshold value, doesn't make sense because the production for every day is completely different. It will be for a dairy industry, one day there has a target value of production, and the other day it will be a different target production. And the water consumption is closely related with that. So the industry needs a dynamic alerting system. Industry needs a alerting system which considers the latest behavior and classify it as an anomaly, the consumption as an anomaly, and normal consumption based on the flow rates. So KNN contributes the best results. KNN gives the best results. The future research areas includes basically it needs a advanced feature engineering for richer data insights. The reason behind the consumption, the data behind more data can be incorporated, and the classification can be done based on that. And there is a class imbalance generally because the anomaly versus normal ratio, always the normal will be high and anomaly will be pretty less based on the current the site scenarios, what happens. And the cross industry application for broader model impact is one of the important thing which has to be considered, because uh, this model has to be generalized. This has to be adaptable for all the industries. It has to be a flexible model which can be implemented to any real-time data, and the user should be able to get alerts and insights immediately. Overall, the results actually is been results shows that this has been very much useful for the industrial application. It also leads a better way to have sustainable water practices for industries and to achieve.
Sorry to interrupt, sir. You have left 1 minute to conclude.
Sure. So the entire system is being especially customized for the industrial applications, and the tweaks here and there could make it generalized for the different industrial domains, and we will be able to generate better results. Thank you.
Thank you, sir. Philip, sir, any questions?
Yeah, so can you just go to your the title page?
Sure, sir. Yes, sir. I hope my screen is visible.
Okay, so actually you are focusing on that how this statistical model as well as the, we can say, the prediction models, right?
Yes, sir.
How they are working for the real time water flow, right?
Yes, sir.
So have you applied this your model somewhere in the real time?
Yes, sir. So basically,
Have you identified the possibilities where this model will be helpful in real time?
yes, sir, absolutely. So currently there is a company which does the real-time water flow monitoring and the dashboard. So it's we have been implemented in that. The architecture which is currently showing in the slide is from there only. So basically the company is serves the industrial clients, and there is a software already in place which is hosted in Microsoft Azure, and this model is being currently running on trial in the Microsoft Azure platform. And for one of the dairy industry, this has been implemented.
Oh, okay, fine. Yeah, this is from my side.
Thank you, sir. Thanks a lot.
Thank you, sir. Moving to the next presentation. I would like to call for the next presentation. I would like to call Rajat Goyal, paper title Customers and Employees Perception Towards CRM Practices Adopted by Banks, a bibliometric analysis. Sir, you may proceed with your presentation.
Yeah, I'm audible.
Yes, sir, you are audible to us.
Yeah, 1 minute. Yeah, my side is visible.
Yes, sir, your screen is visible to us.
Yeah. Yeah, here I'm representing my research paper on customer and employee perception towards CRM practices adopted by banks, a bibliometric analysis. They started with the index. The first is abstract of my paper. The bank in India have been using CRM to understand the diverse needs of banking customers and trying to use the strategy of relationship building customers. We are convincing the customer for technology adoption to interact with the bank in major challenge. The study aims to provide the readers with full of understanding of the current dynamics and shed light on the current status of the literature pertaining to CRM in banking sector. Furthermore, the study offered the comprehensive examination of the existing body of literature of CRM in banking through utilization of bibliometric analysis. The Scopus database was utilized for a data collecting in the study, and the database utilized in the research having the total of 418 documents spanning the year of 1998 to 2023. The analysis was conducted using the viewers viewer, which revealed the research on CRM has exhibited inconsistent progress in scholarly publications. Then we start with the introduction. The concept and strategies of the customer relationship management emerged in early 90s, where organizations recognized the importance of happy customers and their contribution in the success of business. The CRM practices refer to strategies adopted by a business organization to understand the customer expectation with the aim of maintaining good relations with them to ensure the growth in overall sales. The, Traditionally, the bank staff was to manually record the detailed information about the bank's customer. Here, the loan, deposits, reputation, availed, etc. But now, many softwares are available in the market and significantly reduce the burden of the bank staff by keeping centralized record of banking customer. The role of ICT in the bank automation aims to provide a flawless system of bookkeeping, better customer services, and smooth discussion making process. The primary objective of this study is to provide an inclusive examination of the existing body of literature to address the existing knowledge gap of conducting the bibliometric analysis of the current literature of CRM banking. The specific objective of this study is to detail assessment of particular areas that warrant further inquiries, so providing the valuable recommendation for prospective inquiries in the crucial field. Here the literature view, the some of the literature I reviewed in this from in 2021, 20 and 19. Here the research analyst, the latest one is the 21. The research identified and analyzed the CRM that compliance with the promised service and quality in the greatest tool of success, which is return comes with the self-reported loyalty. It is a valuable and important predictor to consumer behavior and consumer purchasing discussions. This result is enormous growth of Islamic banks, which rejoice the comparatively more power and large market base consisting of customers who are strong supporter of religious law and principles flowing organization. Then we start with the proposed methodology. The proposed methodology, the present work utilize the data source from Scopus, a highly recognized and extensively employed comprehensive database among researchers for doing bibliometric analysis across the diverse field. The selection of the scope as the database of choice was based on its status as one of the most extensive bibliographic resources in the diverse realm of the scientific research. The research employed a methodology that involved utilizing a set of keywords with cutoff symbols and Boolean operators, and the keywords customer relationship management was combined with the term bank using the Boolean operator, and the analysis was limited to the discipline of social science, computer science, business, and management. The indicated years of publication range 98 to 2023, with the search conducted in November 2023. The viewer software was utilized by the researcher to conduct the bibliometric analysis procedures. Upon the completion of the file extension process, this software generates visual representation in the form of maps, facilitating the analysis of data derivative from bibliographic reference. These maps are designed to be easily comprehensible and interpretable. There's research and discussion. The table one shows that the year we have taken that, and we number of published article is 418. Then we growth rate of the CRM we used. In table one represents a comprehensive overview of the entire quantity of paper published on the topic of CRM in banking towards with their respective proportions, cumulative percentage and growth percentage. In the year 2019, there was a notable increase in the number of publications as evident by Figure 1 and Table 1. Specifically, a significant proportion of this publication amounting to 30 or 7.18% of the total CRM in banking publication were observed. The projected increase in number of the year 2023 is attributed to the advent of Industry 4.0 and the ongoing technological advancements. There, in addition to analyzing the document source types and source titles, we also concluded an examination of the record retrieved from the database maintained by Scopus. The figure 2 displays the evaluation of documents type conducted in its studies. The predominant form of publishing in the field of CRM in banking is journal articles, accounting for 63.9% of the total paper published. This is followed by the conference papers, which constitute 24.9% of the publication. Book chapter make up 5.7%, and while review represent 2.2% of the overall publications. Here, the using the word shift keyword analysis feature, this study first compiled a word cloud of the author's keyword, and figure 3 displays the results of using a scale and the maximum number of 100 words to generate a word cloud. The figure showed the most often used 100 words or phrases from the CRM in banking article. The size of each word represent how often it appears in the list of keywords as whole. Additionally, the word cloud algorithm display other recently popular phrases such as technology, service quality, loyalty, customer satisfaction, and employee perception and strategic management based on the keyword used to carry the document title. Most relevant terms are those that have been used in studies addressing the issue of customer relationship management in banking
Sorry to
sector.
interrupt, sir. You have left 1 minute to conclude.
Okay, thank you. And the in figure, the viewer in order to identify their co-currencies, the network representation of the author keyword generated using the viewer in figure 4. The visual attributes such as color, size, size of the acres, and the font used or the width of connecting lines serves and indicate the degree of association between the keywords. Here the table 2, the analysis of the keywords correspondence result in the formation of 3 distinct groups, each characterized by a varying number of keywords. Figure 4 illustrates the prominent association between the keyword and relationship management. And the figure 5, there is a represent a visual representation of the leading 10 institutions that have the made significant contributions. The majority of the scholarly investigation pertaining the concept of CRM in banking sector having the conducted at the University of Tehran and University of Delhi and Islamic Azad University. And the figure sees the total of 70 discrete nations made contribution of the body literature CRM, and the India produced the most number of articles totaling 97, with the China following closely behind it 49 pieces. Iran also contributed 49 articles, while United States, Taiwan, and produced 32, 24, and 19 articles. The limitation and the future of the study is CRM in working in the banks accumulate the vast amounts of customer data, and managing this information can become overwhelming, and ensuring the accuracy, security, and relevance of this data constant challenge. Additionally, integrating the various system and database within the bank can be complex and time consuming. And exploring how AI can enhance the CRM capabilities to provide personalized and predict any and real-time customer service would be valuable. And additionally, the studying ethical implication of AI in CRM, such as data privacy, transparency, and customer content, and would be crucial or ensuring responsible for implementation. The conclusion of this study aims to investigate the rising trend in CRM. The study employed descriptive analysis by doing an examination scope of analysis and bibliometric analysis. The utilization of the bibliometric analysis was employed in order to ascertain and the progression of this keyword. The data set was obtained by utilizing the Scopus metadata, subsequently analyzed using the viewer software. it may be inferred, and during the course of 2 decades of study in CRM in banking sector, there has been constant and progressive growth in the number of quality of research papers. In conclusion, this bibliometric analysis of research on CRM in banking sector offers more comprehensive and worldwide landscape collaborative networks. That's the result of this study provide a solid basis for future research efforts, delivering valuable insights of academic and professional as they explore the relevant topics and contribute to the existing body of knowledge of CRM in banking sector and CRM in other financial institution. Here some references I have used in my paper. Thank you.
Sir, any questions?
Hello. Actually, I can see
Yes,
that
sir.
the title you have selected, right? The
Yes, sir.
title, yeah, Rajat, you have selected. It is, I think, a bit innovative, right?
Yes, sir.
But my point is that what ultimately your observations from this, your ultimately you would like to say,
Sir,
like to
actually,
say in
we
a
are
one or two sentences, because whenever you are doing this kind of the analysis, I think okay, I can see that you have put enough graphical things, but what is ultimately your observation, how you can even do something more in this your topic?
Sir, CRM is getting popular and necessary in a today limit. Actually, the we are distributing the two types of banks in a private bank or a public sector bank, and we are doing that private sector bank already using this technique CRM and enhancing their customers and their giving loans more than the public sector banks. Public sector banks not giving such kind of service to them their customer. That's why I'm using this study to explore further. Yes, sir.
Okay, fine. Okay.
Yeah, thank you, sir.
Thank you, sir. Moving to the next presentation. Now I would like to call for the next presentation. I would like to call J. Sangeeta Archana for the paper title Development of Metaverse Based Experiential Learning Platform to Enhance Shape Recognition Skills in Autistic Children. Ma'am, you can proceed with your presentation.
Yes, sir. Sir, is my screen visible?
Yes, ma'am, your screen is visible.
Okay, sir. Okay, I'm Sangeeta Archana, and our team members are Dr. Punkul Elias, Vishnu Darshan, Varun Adhavan, and I am here to present my topic, Development of Metaverse-based Experiential Learning Platform to enhance shape recognition skills in autistic children. Abstract. Children with intellectual disabilities find it more difficult to learn basic concepts or learn new skills than a normally developing children. These are due to their neurodevelopmental conditions. They find it more. They are more sensitive to sense such as lights, sounds, textures, smells, like etc. So it makes them to difficult for them to concentrate in classroom or to complete a particular task. And there are in many schools that provide a proper care or support to the children. So they need an effective teaching method to understand the abstract concepts well. Uh, these children may excel well in visual learning and learn than the traditional method of teaching. So our proposed system implements experiential learning platform in a metaverse environment for children with intellectual disabilities to learn about basic shapes and their properties. So our platform's effectiveness was assessed using the pilot study that involves 10 autistic children. This platform is highly adaptable and user friendly, which can be customized to an individual needs. introductions. Nowadays, special schools is facing more challenges because of their traditional way of teaching, and also it must be presented in front of their caregivers. During COVID-19, parents find it more difficult to take care of their children education due to their necessary equipments. So, and also to ensure children should understand the basics, we need creative solution that will work with any environment. Understanding basic concepts will create a foundation for their learning new information or adapting to any changes. So, the emergence of metaverse offers numerous possibilities that may improve the lives of people everywhere. Metaverse technology uses virtual reality and augmented reality technology that immerse users in a digital environment uh, where users can interact in that virtual world. So, because of this change, education is now more accessible to people of all socioeconomic backgrounds. Uh, Review. So, there are many papers related to metaverse technology, especially in the field of education. So, these papers provide a promising results that children can learn in an metaverse environment. So first one is development and application of metaverse-based social skill training program for children with autism spectrum disorder. So in this, they have created a metaverse environment for their social skill training. It increases the accessibility and engagement in social skills training of the autistic children. And next one is development of intelligent system based on metaverse learning for students with disabilities. In this paper, they have created a 3D virtual learning environment in metaverse, and also they have used a Moodle learning management system for attempting quizzes or chat room sessions. So this one improved the skill level of the particular experimental group's children. And next one is interactive number learning augmented reality application for autistic preschool children. Here they have created mobile app that using augmented reality displays. They uses flashcards uh, to teach the particular children. So this have improved their personalized learning experiences and also provided some visual and auditory cues to their children. And next one is Ratsel, a game-based evaluating tool for Dicelik using augmented reality gamification. This application was created using augmented reality technology, and the inference was they can automatically adjust their difficulty levels and provides feedback based on their performance. And next one is effective learning design of game-based 3D virtual learning environment for special children. In this, I have created a 3D virtual environment for learning purpose. This environment has improved the vocabulary, sentence structure learning techniques for four special students aged between 8 to 9. So this is our metaverse framework. Here users, the autistic children can register themselves as a avatar in the metaverse environment. They can choose in the learning content to learn the particular shapes and their properties. Here we are using basic shapes, four shapes: circle, rectangle, triangle, and square. After viewing the particular content, they can uh, they can proceed to the next phase as assessment phase. It contains with assistant and without assistance. The assessment phase is to take the test the knowledge of the particular children, how well they have learned the particular content in the metaverse environment. So the learning scene in the metaverse consists of 3D scenes, texture maps, characters, audio, video content. So avatar. So children can create their own avatars and enter into the metaverse environment to study about the basic geometric figures. Here they have to use the virtual reality headset to enter this metaverse learning environment for viewing the shapes in variety of angles and learn more about their properties. Virtual classroom environment. Blender. Here we have used Blender to create the uh, virtual classroom environment. Blender can render objects in real time. Then we can export this particular object into the Unreal Engine 5 where the entire metaverse map is created. So the models made in Blender are then imported to Unreal Engine. It will be placed in the appropriate places. So after that, OpenXR plugin is used to add a virtual reality character model that that the user can navigate in the metaverse environment itself. So this is our created metaverse classroom. Learning content. So in the learning content, the instructor, it is a 3D object model rendered using Blender software. Here the instructor will provide the live demonstration of the basic shapes and their properties. So the created virtual shapes is featured with
Sorry to
3D
interrupt,
shapes.
ma'am. You left 1 minute to conclude.
Okay, sir. Okay. In the assessment phase, they have to test their performance based on the quizzes. The quizzes may contain design the particular shape or locate all the objects in the classroom, like. And the learning scene consists of it will be consists of 3D objects, and the texture maps are uh, used for the visual representations that contains colors, reflectance, and surface roughness. And 3D mesh models are used to serve as the foundation for shape recognition. And audio video contains used to demonstrated about the particular shapes. So here we have used to create Blender used to create the particular shapes. We have used square, rectangle, circle, and triangle. So evaluation. So we have evaluated the particular platform in the presence of experts in autism, caregivers, and the educators. They have provided valuable feedbacks. So also we have to regularly monitor this platform so that we can adjust the environment according to their unique challenges and strengths of the autism children. After the validation, pilot testing is conducted for 10 autistic children. Assessment based on attention span, ease of use, accessibility, and social skills. So our students has provided the feedback based on the attention span, ease of use, accessibility, and social skills. Uh, so it increases the attention span of the autistic children. It also facilitates social interaction and communication of children. They can recognize shapes uh, based on their learning style. So conclusion, we have created a metaverse learning platform to recognize shape, and in future research we will additionally include much more shapes and more properties that will boost students retention of knowledge. Thank you.
Thank you, ma'am. Such a nice presentation. The session chair
Thank
is
you, sir.
currently not having any questions, so we are moving to the next presentation.
Okay, sir. Thank you, sir.
So for the next presentation, I would like to call Sunil Kumar for the paper title Enhanced Flood Forecasting Revolutionizing Prediction with Federated Learning. Sir, you may proceed with your presentation. I think so, due to some network issue, he's not being in the meeting. We are moving with the next presentation. For the next presentation, I would like to call Harshal for the paper title Facial Expression Recognition Using Convolutional Neural Network. Sir, you can start with your presentation.
Yes, sir. Is the screen visible?
Yes, sir, your screen is visible to us.
Okay. Uh, good afternoon, everyone. I am Harshal Tunde. It's a pleasure to be here at the SmartCon 24 conference. Thank you for joining, everyone. Let me introduce all the authors of the research papers, which are Chirag Bam, Harsh Mata, Ved Agrawal, myself, and Dr. Ramchan Hablani. Today we are diving into the topic facial expression recognition using convolutional neural network. Over the next few minutes, we will cover topics such as importance of facial expression recognitions, its applications and impact, followed by the work that we have done. Coming to the importance of the facial expression recognition, it is critical for effective communication across diverse fields like education, hospitality, and surveys used for assessing students' comparison, monitoring patients' well-being, and for customer satisfaction in service industries. Applications and impacts significantly enhances human-computer interaction, emotional understanding, and marketing strategies. Plays a pivotal role in education by measuring students' attentiveness, aiding healthcare through emotion analysis, and supporting customer-centric approaches in retail. The benefits of the models that we have created, it is in different fields, like in education, it improves the students' involvement by measuring attentiveness during lectures. In healthcare, it facilitates in pain management through emotion analysis. In retail, it can evaluate customers' happiness. So there are basic facial expressions classified into seven major categories that are anger, happy, sad, neutral, fear, disgust, and surprise. So coming to the literature review, so we have come across the various research papers and we have taken them as a baseline and developed our model above them. So we have mentioned here two of the research papers. The first one is the deep facial expression recognitions. In these research papers, they have used the FER data set to develop their model, but the research gap, or we can say the research papers lack in the data set. Like the data set is a very old data set, so their accuracies are not that high. The second research paper is a facial emotion recognition using deep learning review and insights. In these research papers, they have also used the FAR data set, but they have used some different innovations to make the CNN architectures. But these research papers lack some deep learning aspects, like they have not considered the epoch and the batch size, which can eventually increase the accuracies. But we have taken care of that in our model. Talking about the different data sets that we have used in our model, the first one is the FAR 2013 data set, and the second one is the RF data sets. All the facial expressions that are related with these data sets are mentioned. And the FAR dataset is a publicly available dataset. It consists of approximately 36,000 static images. All of them are black and white images. And the second one, that is the RF database, it consists of approximately 30,000 images. But these are the colored images. So this was an overview of the dataset. And now coming to the methodology or the steps that we have done to build our model. So the first step is to collect the dataset, which I have previously mentioned in the previous slide. The second one is the pre-processing of the dataset, where we have cropped images in order to particularly focus on the face. So for this, we have used the hard-casted model, which is one of the object detection model. Then after that, we have trained the model, followed by testing, and then finally deployment of the model. So this is how our model works. After testing of the model, uh, we are giving an input as a particular frame. Then from that particular frame, the face is detected using hard cascade model, and then the feature extractions is done. So out of these seven expressions, the one having more confidence value is the result for a particular image. Now coming to the layers of the CNN architectures. So before that, like the datasets which I've mentioned, so we have bifurcated the datasets into three parts. The first one is the training dataset, followed by validation dataset, and the last one is the testing dataset. So we have given 80% of the images for training dataset, 10% of image for the validation dataset, and remaining 10% for the testing dataset. And then we have built our architecture. So these are the layers of our CNN architectures. We have built it from the scratch, and we have not used any pre-trained model. So it mainly comprises of Con 2D, max pooling, flatten, and dense layer. So these are the four layers which consist in our model, having the first parameters as the filter size, followed by kernel size, and all these layers have an activation function as ReLU, which is one of the activation functions in order to perform this layer. And then finally we have in the last dense layer, we have an activation function and softmax. And using model.summary, we can predict the particular emotions. Finally, coming to going deep dive into the layers. So the work of the con 2D layer is used to find the patterns in a particular image. The work of the max pooling layers is to take the necessary patterns from the con 2D layer. Then the flatten layer simplifies that particular pattern, and the dense layer finally takes the input from the flatten layer, and it then makes the prediction based on the input. So, in our working, what we have done is we have varied different parameters such as the batches, the number of epochs, and also the layers in our model. So, while working with our FVR data sets, firstly we have taken 50 epochs, which results in a testing accuracy of 84.85%. This is the confusion matrix for the same model, where the first column determines the true labels and the first row determines the predicted labels by the model. So this is our model for FER dataset. It is a confusion matrix for that. Then coming to the predictions of the FER dataset, this is the visual representations. Like each and every image has their actual image followed by a predicted image and the confidence level associated with each and every image. Now coming to the RF dataset, in RF dataset, we have firstly varied the batch size, taking batch size as 32, 64, 128, and 256, and we have got the respective testing accuracies as here mentioned. So this is firstly we have varied the batch size. Then we have varied the number of layers in our model. So firstly we have taken a 5 pairs of convolutional max pooling layers. Here we have taken 50 as the epochs, and which results in 93% accuracy. And in the second one, we have taken 3 pairs of convolutional max pooling architecture. Yeah, here also we have taken epochs as 50, resulting in an testing accuracy of 96.35. Lastly, we have varied the number of epochs in our RF dataset model, taking epochs as 15, 25, 35, and 50. And here are the respective testing accuracies of all. So here we can see that at epoch 50, we are getting our maximum testing accuracy of 96.35. So here we have concluded that having epoch size as 50 and batch size as 32, our models gives us the best prediction on RF dataset, having testing accuracy of 96.35%. So this is the confusion matrix for the same model having accuracy 96.35%. So as you can see, the first row indicates the predicted labels and the first column indicates the true labels. So this was the accuracy for our best model and the confusion matrix for it. This is the prediction on RF dataset. So it is similar to that of FI dataset. Just here we have changed the dataset. So each image has their actual label, predicted label, which is given by the model, and the confidence level associated with each and every image. Finally, talking about like to enhance the user experience and to better visualize the output, we have also developed a web application for it. So in front end, we have used the React and Material UI for styling, which have some inbuilt features like navbar and etc. And in backend, we have used the Fast API, which is one of the Python backend framework, and we have used REST APIs, which
Sorry to
includes.
interrupt, sir.
Yes, sir.
You have 1 minute to conclude.
Yes, sir, sure. So like we have REST APIs, which includes various inbuilt methods. So we have our model in our backend, which takes the image and like it gives us the label and confidence associated with each and every images. So these are some of the outputs that we have shown here. And this was all about our finding. Like after varying various parameters, we have got a testing accuracy of 96.35, and we have also extended our work in the micro expression detection. Thank you.
Okay, so please go to your the I think the framework slide.
Yes, sir. So this one, are you talking about the model architecture?
Somewhere in the framework you started with testing. The
Yes.
first block I have seen it was related to the
Yes, sir.
and this I think you have started with testing. So I would like to know that why you have started with testing.
Sir, like here we have firstly build the model, then after building the model, we have design here. Like after, like
No,
firstly we have
normally it starts with the kind of the you have a data set, right?
yes, sir.
So you have to do some kind of the pre-processing,
Yes, sir. Yes, sir.
right? And then you can do subsequently things. You have mentioned testing. So means what you are doing in that first, that in this block testing.
No, sir. Like here we have for testing, it means like we have firstly made our model, like we have collected the data set, pre-processed it, and then we
Okay.
have trained the data set, and after
Okay.
that, what actually the model
Okay.
works like.
So yeah. So you can present this first block in a like that. You
Yes,
are
sir.
doing this kind of a things in a testing, right?
Yes, sir. Yes.
Yeah, so it will I think become more clear. Yeah. Okay. Okay. Yeah. Other things are fine. Yeah. Okay.
Okay. Thank you, sir.
Thank you, sir. Moving to the next presentation. For the next presentation, I would like to call Chandan Kumar for the paper title Forecasting Political Security Threats, a fusion of lexicon based and ML approaches. Sir, you can proceed with your presentation. I think so, due to some network issue, he's not being in the meeting. So let's proceed with the next presentation. For the next presentation, I would like to call Akhilesh for the paper title Late Leaf Spot Detection and its Effect on Pod Quality of Groundnut Plants using Deep Neural Network, a review. Sir, you can proceed with the presentation.
Hello, good afternoon. Am I audible?
Yes, sir, you are audible to us.
Yes. Is my screen visible?
Yes, sir, your screen is visible to us.
Yeah. Good afternoon, one and all. I am Akhilesh Gadakar presenting this paper named Late Leaf Spot Detection and its Effect on Board Quality of Groundnut Plants using Deep Neural Networks, a review. Here are the authors. It's me, Suvarna Kanak Reddy, Priyadarshini Kalwad, B.N. Motigi, and Ashok Chikreddy. We are all from Keli Technological University, Hubballi, Karnataka. And thanks for giving me this opportunity to present my paper on 8th conference SMARTCOM 2024. Here are the contents of the presentation. First, we will start with the introduction, then literature survey, then we will be identifying the research gaps, and then proposed methodology, data preparation for the analysis, and then we will be doing result analysis, conclusion, and then finally references. Here the introduction goes. Groundnut, commonly known as peanut, plays a crucial role in global agriculture due to its versatile applications in food, oil, and feed industries, contributing significantly to food security and livelihoods. Late leaf spot. It is a major disease to the groundnut crops, which is caused due to some pathogens and some fungi, uh, which will be impacting the photosynthetic activity as well as the final yield of the plant. The advancements in the neural network algorithms can transform the detection of the late leaf spot, which is a disease in the uh, groundnut plants, which will be affecting the plants during its late uh, 60 days or 90 days stage, which will be impacting the photosynthetic activity as well. The advancements in neural technology, neural network algorithms can easily predict and diagnose the severity of the disease and can revolutionize the farming methods uh, revolutionize the farming methods over the manual techniques. Then what is the late leaf spot? Late leaf spot is a foliar disease which can be also called as leaf related diseases. The fungi and other pseudomonas, xanthomonas like pathogens can affect this late leaf spot. Mode of spreading can be through rain, irrigation, and infected plant materials. You can see the images in this slide showing the spot surrounding with yellow circles. These are the spots produced due to the late leaf spot. The symptoms can be ranging from reddish brown to the dark brown stage till the end of this disease. Impact of this disease can be stunted growth of the plant as well as the plant yield. Then disease management can be done through the chemical and biological methods, and varieties of resistant uh, uh, varieties of resistant chemical and other methods. Then going through the literature survey, I have studied some of the papers which were published recently. Most of them were 2023 published and 2022 published. In some of the I have done the literature survey in three parts. The first part is disease identification in various crops. In the first literature survey, I came across disease identification using image classification, CNN, and transfer learning, where the dataset used was a plant village dataset, and the accuracy was around 87% to 99.81%, which is achieved. And similarly, we can see the other disease identification in crops like tomato, potato, corn, wheat, and barley, and some other plants also, where the accuracy of percentage ranges from 73.07% till 94.74%. The second part of the literature survey was various plant quality and yield prediction. In this, the objective of the study was to evaluate the genetic diversity in groundnut crops and assessing the peanut pod quality using resonate architecture. As mentioned, it is related to various plant, identifying the plant pod quality, which can be in different plants also. In the third literature survey, I have concluded I came across the identification of the pod quality and prediction of the pod quality in the soybean plant. They have used many methods like multivariate analysis, resonate architecture, and some have also used the YOLO V5 model. So the third part of the literature survey was using the manual techniques and ML techniques, which was the best. The aspect which were considered in this literature survey was data collection, accuracy, scalability, training time, and adaptability. Uh, upon the uh, upon the study, I came across the result as machine learning techniques will be more effective than the manual techniques, because manual examination and expertise may require many manual efforts, but we can also use machine learning tactics and other IoT devices to collect the data set, uh, as well as the prediction of the disease and other methods. Then what were the research gaps? Necessity of a user-friendly mobile or web interface for instant disease monitoring was not available, and fine-tuning of the if the mobile or web interface app or web interface is available, then the fine-tuning of the pre-trained models for quicker convergence and improved generalization was also not available. Then integrating the cameras or sensors for continuous monitoring and providing the early warnings for enhanced disease management can also be considered for the research gap. Then this is the proposed methodology. When we give the method which we are following is to develop a user-friendly mobile app or web interface, which will be helpful for the farmers as well as the common layman to understand what disease the plant is now suffering from. The first step of this methodology goes into the leaf image input, and then the image will be classified into the uh, different disease based on the labels which will be provided during the training time, and then it will uh, it will be processed for the disease severity identification using the algorithms which will be designing. And after that, the predicting after we get the pods or any other fruits from the fruits, meaning the output or yield of the plant, we will be getting the prediction of the pod quality based on the previously given training data set. We are also we will be also focusing on the smart recommendation system, which will be giving uh, more insights about the weather conditions as well as the disease management techniques. Then we collected the data sets from the Agricultural University, Dharwad, which is located in Karnataka, and we collected the images of the leaves, groundnut leaves, in the uh, span of 90 days with the interval of 30 days each, and we collected 3 different genotypes naming DH256, JL24, and GPBD4, which were resistant, moderately susceptible.
Sorry to interrupt, sir. You have left 1 minute to conclude.
Okay, thank you. Resistant, moderately susceptible, and susceptible. Collected 250 images in each category and in each stage. We totally collected 2000 images, which were in JPEG format, and the standard image size was 224 cross 224. The next process was to process the data, pre-process the data. The raw images were collected like this, were like this, and then cropped images were focused on the most important leaf in the raw image, and after we will be removing the background of that image, and the image classification based on labels was performed. The data preparation, uploading the labeled images covering diverse categories, and splitting them into the test and train dataset to initiate the process, and then automated processing and splitting was done. After that model configuration and training was done, we employed MobileNet v3 model for our smaller size on the mobile app, and the model undergoes training being fed through the dataset. The weight and other parameters are optimized to improve the accuracy. After that, we will be evaluating and tuning the model to set it into the mobile app. Uh, After that, the flexible deployment was done using TF Lite version of MobileNet v3 and deployed it on a mobile app. The architecture diagram will be looking like this. The built model was of 32-bit size. Then we will be quantizing that model to 4-bit size to set it in a mobile app and reducing the size of the mobile app, and then fine tuning the model using other parameters. Then accuracy and the model size also reduced. Accuracy was increased and model size is reduced. Finally, we deployed it on the edge device. Then this was the implementation result. When we implemented this mobile app, the camera turned on and spotted the and when we give the input as a image, it will be giving the result as in the first image. We can see that the first disease is identified as rust, and the accuracy is nearly 100%, and most accurately is 100%. And the second image is showing the late leaf spot image, which is also identified as 100%, and this is the healthy image, which is considered multiple leaf images, and it's giving the accuracy as 99.99%. Then after having this mobile application done, we can also fine tune this mobile application for different images and multiple image detection in multiple plants, and real-time disease monitoring with IoT devices can also be done. Here is the conclusion: significant increase in disease detection accuracy with deep neural networks, surpassing the traditional methods. It means traditional methods can identify the disease and can also uh, prevent those diseases from prevent those plants from those diseases. But we can also use deep neural networks for faster and better management of the disease. Notable reduction in the misdiagnosis rates under experimentation. Crucial emphasis on timely identification of late leaf spot or other diseases in the plants for preserving groundnut pod quality or other plants pod quality and yield. Practical significance of implementing advanced computational techniques in agriculture got highlighted. And finally, expected increase in the efficiency within groundnut cultivation through the application of advanced technological solutions, including IoT devices, can also be done. These are the references, and thank you.
Good, sir. Any questions?
Hello.
Hello, good
Yes, sir,
afternoon, sir.
you're audible.
So, topic you have actually selected is very good and the relevant. Now, the point is that have you contacted or with any the agriculture organization or like that
Yes, sir. We have done it under the guidance
to
of the.
explore what kind of the yeah. Yes.
Yes, we have done this study under the guidance of the Agricultural University, Dharwad, which I have also mentioned in the presentation. We
Okay.
have some student guide as well as the professor guide in that organization. He will be helping us, and he has helped a lot in data
Okay.
preparation and data collection also. These are the real-time data images collected on the mobile phone, and after pre-processing, these are the images.
Okay. Okay.
Thank you, sir. Moving to the next presentation. For the next presentation, I would like to call Aritra for the paper title Location Jamming of Radar Waves Using Software Defined Radios. Sir, you can proceed with your presentation.
Thank you, sir. Can you hear me?
Yes, sir, you are audible to us.
Let me just share my screen once.
Yes, sir.
Yeah, so I think you can view my screen, right?
Yes, sir, it is visible to us.
Okay. So good afternoon to the respected chair and my fellow presenters. I am Oritra Khashnovish, and on behalf of my co-author, Dr. Kriti Bhushan, I will be presenting my research on the topic of location jamming of radar waves using software-defined radio. I briefly want to show the contents that I will be presenting, and then start the introduction, introduction brief introduction the top I will deliver. So one of the topics, the crux of the topic is radar. Radar is an electromagnetic wave that is related of surfaces and which can be used to detect other objects. Think of it as kind of like an echolocation that bats or dolphins use in Mother Nature. This is used in both civil and military affairs. However, today we will be covering only the military applications. One of these military applications is tracking critical targets during warfare. And if we are on the receiving side of this tracking, our critical infrastructure might be hit by long range enemy precision weapons like missiles, etc., and drones. To counter this, we use electronic countermeasures or ECM to jam the radar signals. Some examples of ECM includes noise jamming, uh, deception jamming, which further consists of range jamming or velocity jamming. Today, I'll be talking a bit more about velocity jamming. Now, one of my goals was to incorporate the paradigm of software-defined networking into radar jamming. So, what is software-defined networking? Software-defined networking is composed basically splits the network into two parts. One is the control plane and application plane, and the other is the data plane, where the actual data transfer takes place. One of the devices that it can be that is a further development of software defined networking is software defined radio, which is a programmable wireless transceiver or a programmable radio which uses the SDN paradigm. I will be later showing the architecture of the SDR we have implemented. So problem definition as you can see, our goal is to jam radar and take our optical asset by using velocity jamming ECM through a software defined radio. These some of the real works I have consulted in my reach. Most of deal with jamming, how and how we can distinguish radar signals and ECMs, or one of them also also about ECC or even countermeasures, so as to prevent the jamming of the hostile aircraft from our jammer. So these are the related works I have consulted. Now, regarding the work I have done. So regarding the work we have done, we have basically created 3 modules. One is an angle calculator, which is used to determine the angle of azimuth and elevation of the non-cooperative source, or NCS, which is another for the target sensory six. The second is a little frequent memory, which is capable of listening, storing, and repeating back the radar's transmitted signal. So as this module is the brains behind the operation, and basically is responsible for creating the jamming waves by analyzing the radar signal received. And there is a recalculator which is used to calculate how far the NCS is from the jammer. So as you can see, this is the SCA, or software communication architecture, of the jammer we have planned. This is based on the SDR architecture, whereas you see that is below the above the hardware. This is the OS, and above that is the various modules, the DRFS, the wave analyzer, and the VGPO jammer, all work in tandem to break down the radar waves received and craft the jamming wave to send to the NCS. The range tracker is also sends data to these components in order to pin the location of the NCS. The various components communicate with each other. So you the middleware broker architect, and the feature interface FSI, and the feature service interface FS. Now, as you can, this is the flowchart jammer. First, the radar antenna detects the radar waves. If it detects radar wave, then we come to an angle elevation and angle of azimuth for trigger the receive radar and activated. After which we come to mingle of elevation and as for all of the receivers have activated. If the mean angle, then we find out the variance of the entire set of angles of azimuth and angles of elevation. If the variance is above a certain threshold, which we set eta, we will discard all values with high variance, because that might cause some problems in pinpointing the NCS's location. After which we will input additional angles like guess angles to further pinpoint the location of the NCS, and so as to calculate the final angles of azimuth and elevation. These are the equations that I have derived for calculating the angle of azimuth, the angle of elevation. The angle of azimuth is basically the angle in the XZ plane, while the angle of elevation is the angle calculated in the XY plane. And below this is the jamming to signal ratio.
Sorry to interrupt, sir. You left 1 minute to conclude.
Okay, sure. Thank you, sir. So JSR is basically showing the ratio between how powerful our jamming signal is to how powerful the radar signal that is reflected is. This should always be positive, and the distance is the roundabout is the approximate distance from of the NCS from the jam. As you can see, this is a graphical signal comparison at the NCS's radar. So the blue line, which has been simulated on MATLAB, is used to show the noise that is present. The green line shows the radar signal from the target, and the red line shows the jamming signal. Due to the high amplitude of the jamming signal, it is expected to overpower the reflected radar signal. This is what happens according to this is the experimental results which has been simulated on NS3. The zero represents the jammer, one represents the NCS, and two represents the actual target velocity, and three represents the velocity that is observed on the jammer radar. As you can see, due to the jammer sending a signal to the CS, the 2 and 3 which should be together are separate, and jammer sees of them are coming in separate velocities and directions. So this is the conclusion. We have developed a process and architecture for implementing a velocity jammer using an SDR. So which in turn jams the location of the critical target. However, there are many challenges which we face. Delay handling and big data, along with single point of failure, is a major issue still in SDN networks. And other challenges include hardware challenges. We had to simulate this. There were times we could not simulate this on an Arduino, which we tried, but we could not. We also have to remove a lot of concessions in environmental constraints. Calling that the other party is CM. And we need to improve upon more OT earn. Now, this experiment to simulate on a hypervisor to stay true to the architecture. But the other ends that are that is.
Thank you, sir. Kirit, sir, any questions? I think so, sir. Don't have any questions. So let's move to the next presentation. For the next presentation, I would like to call Vijay Kumar Upadhyay for the paper title Real-Time Obstacle Detection using YOLO V8 on Raspberry Pi 4 for visually challenged people. Sir, you may proceed with your presentation.
Thank you. Am I audible?
Yes, sir, you are audible to us.
Is my presentation visible?
Yes, sir, your screen is visible to us.
Okay, thank you. Good afternoon, everyone. Respected session chair, Dr. Kirit Modi, and reporter Kartik Bharadwaj, and my fellow presenters presenting this session. I am Professor Vijay Kumar Upadhyay, working in Tripura Institute of Technology. This is a part of an ongoing work which I am presenting, real-time obstacle detection using YOLO V8 on Raspberry Pi 4 for visually challenged people. My co-authors are Piyush Kanti Datta Pramanik, Priyanka Roy, and Rituparna Sen. The presentation has been outlined in this manner, so I'll be touching upon each and every aspect of these topics. We know that how challenging it's the life for a visually impaired person. When we put a cloth in our eyes, we can understand their pain and their difficulties, the day-to-day challenges which they face, which actually we normal human being with all organs in working condition, we cannot, feel that. But there are so many challenges they used to face. uh, to ease their life, to make their life comfortable, and at least, especially in terms of mobility, there has been lot of efforts in the literature, lot of works are there, but still there is scope for improvement and making their the gadgets that has been developed user friendly, and so that they can lead a better life, quality of life improves. In this research work, we have made an effort to implement one of the very latest deep learning algorithm, Yellow, to implement on Raspberry Pi platform, which is a single board computer. And we try to experiment with different types of objects, so that the effectiveness of yellow V8 algorithm and implemented on the very smart and advanced Raspberry Pi 4 kit, how it responds in different obstacle scenarios that were experimented. So the key contribution of this work is successful implementation of Yellow V8 deep learning model on Raspberry Pi 4 platform. We have used several case scenario considered to assess the performance of the proposed system, and based on the assessment, several inferences are obtained for practical considerations, not only for our work to continue, also this will help our fellow researchers to carry forward this work. uh, Yellow V8, which is one of the very latest release from Ultralytics. It was launched in 2023 January, which has been experimented in this work. Raspberry Pi is one of the very latest hardware platform. In many cases, this is used as an edge device, and it is very suitable for real-time application. It's a very fast and very effective platform for experimentation and development of prototype. uh, in this particular experimentation, here image sensor, we have used Raspberry Pi camera, which is compatible to Raspberry Pi 4 through the camera serial interface port. This is the experimental setup. On the right hand side, if we see, this is the Raspberry Pi 4 board, very small credit card size board, which is connected with the Raspberry Pi camera through the camera serial interface port. And this, in this framework, as we can see, uh, the objects of variety types, here basically 4 types of objects has been considered in our experimentation. So objects are at a radial distance from the camera, which is one aspect of our experimentation. And second is the separation between the objects. So by varying the distance between the pi camera and the objects, and also for various separation, we try to assess the effectiveness of Yellow V8 algorithm implemented on Raspberry Pi platform. So on the hardware, as I have told, that Raspberry Pi has been used, which has been powered by a 5-volt 20 k milliampere hour lithium ion power bank from Duracell. And the software framework and dataset that are being used, obviously Raspberry Pi has a official operating system. Raspberry Pi Bullseye 64-bit version has been used, OpenCV library, datanet framework, and most importantly, the Nano Yellow V8 Nano version with pre-trained Coco dataset has been utilized in the research work. So in the proposed methodology, initially, since it is a implementation, a hardware related, a prototype development related work is there, So we often find a lot of compatibility issue, lot of challenges when we go for actually implementing our different type of sophisticated algorithms. So our started with setting up of Raspberry Pi 4 with installation of its OS and other frameworks, configuring the Raspberry Pi camera over here, followed by installation of the OpenCV with latest version, then installation of Ultralytics Yellow V8 package on it. These poses so many challenges because as there are, I mean, when there is a change in the version, many of the compatibility issue comes. So setting up the platform itself take a lot of time and a very careful configuration. So moving ahead, thereafter, once successfully done, we have run the pre-trained model on different scenario, which and we have recorded the output, which we'll
Sorry to
discuss
interrupt,
as a
sir.
result.
You have 1 minute
Yes.
to conclude.
Okay. So accuracy, actually, normally in machine learning algorithm, these are the accuracy, I mean, equation used. And in this case, we have slightly modified the equation for suiting our purpose. So in the result analysis, we have kept 6 use case scenario. We have kept different chairs, I mean, over here, and we try to identify uh, how much accurately our algorithm can detect it. As you can see that we started with 1 chair and we move up to 5 chairs, and we have seen that in this scenario all has been detected with 100% accuracy. In the second case, where we know that yellow algorithms are very effective in identifying objects inside the object, embedded objects. So in one chair it is blank, and other chair it is a teddy bear has been placed. So in this situation, when we try to vary the distance between the objects, we can see when the object distance is 190 centimeter, the teddy embedded in the chair could not be detected. But when the distance has been reduced, the teddies has been, I mean, identified correctly. So the distance variation we could identify, I mean, infer that the yellow object detection. And here, if we see the 8 potted plants on different 7 vases in one ball, similarly 6 potted plants and 5 vases and one in ball. So, and with keeping distance fixed and separation varying, here 10 centimeter, here 15 centimeter, we can see that the accuracy is varying with distance between the camera and the object and separation between the objects. Similarly, another test case has been here used. It is 4 potted plants on vases. So different distances has been varied, and also the separation varies. We can see that there is a difference in the accuracy, and obviously, if the uh, objects are more closer to the camera, their accuracy is better, and also separation is more than accuracy is better. So that thing has been experimented with bottles also, almost similar type of results we could identify. And when we have done increase the number of bottles, so results are available here. So in conclusion, I can say that this is an effort to understand the effectiveness of yellow V8 algorithm on Raspberry Pi platform to detect real-time objects, which this sort of experimentation will be very much useful uh, for converting it into smart stick. And there is, since yellow V8 is relatively heavy deep learning platform, what we have observed that when it is used on the Raspberry Pi for longer duration time, overheating of the board takes place. So proper heat management is required. This is one of the challenge. And in future, we are going to expand this work so that the visual information that can be converted into auditory, so that it can be suitable for visually challenged persons. So these are the references that has been used during the experimentation. Thank you very much for giving me the opportunity. Thank you.
Thank you, sir. Kids, sir, any questions? I think so, sir is not having any questions. So let's proceed for the next presentation.
Okay, thank
For
you.
the next presentation, I would like to call Mr. Surya with a paper title YOLO V8, the AI-enabled detection system, cataract detection system. Sir, you can proceed with your presentation.
Yes, sir. Thank you. Am I audible?
Yes, sir, you are audible to us.
Yes, sir. Yes, sir. So is my screen visible, sir?
Yes, sir, your screen is visible.
Okay, thank you. So, hello everyone and good afternoon. I am Surya from SRM Institute of Science and Technology, and I am very glad to present my project today, which I did along with my team members, Satya and Tarun Surya, under the supervision of my ma'am Angeline. So, and my project is YOLO VI, the AI-enabled cataract detection system. So, coming to the introduction, cataract, a cause of vision loss and blindness worldwide among older individuals, affects almost half of the elderly population in India. And the primary objective is to deploy a deep learning model for the classification of cataract and eye images. So the intention behind this initiative is to streamline and automate the process of identifying cataracts within the eye images in real time through uploading images or videos of the eye, where the YOLO V8 model provides the reliable solution. So coming to the abstract, early detection and treatment of cataract is very crucial to prevent vision impairment. So we use the YOLO V8 algorithm, which is a deep neural network algorithm and also known as a deep learning algorithm that can detect cataracts with very high accuracy and speed. So we use this YOLO V8 to compare with other models, other existing models such as Inception V3, VGGNet, AlexNet, and even ResNet 50, where our YOLO V8 algorithm outperformed every other existing models. So coming to the objective, uh, detecting and treating cataract is very crucial in preventing a permanent vision loss. So uh, the YOLO algorithm, you only look once algorithm, is renowned for its effectiveness in object detection. The speed and efficiency makes it an excellent choice for real-time applications. So the YOLO V8 algorithm shows a promise method for automated cataract detection in real time. So the problem statement is that there is a shortage of ophthalmologists and a rise in the number of cataract patients, which is leading to many patients who are unable to obtain adequate surgical care. So the delay in cataract surgery can lead to worse conditions of patients and even in vision loss. So we use artificial intelligence uh, to and cataract diagnosis using naked eye images in conjunction with real-time camera images, which is the best possible way to address this problem. So the aim of our project is to detect cataract through deep learning with the help of this YOLO algorithm. So coming to the implementation, uh, we uh, we train this model. We train the YOLO model, which showed the results of 95% accuracy. So after deploying the model, we capture the image of the naked eye in real time using the webcam and through proper lighting, where the features of the eye are extracted and compared using the trained pre-processed images. So the results are displayed through light feed. So talking about the YOLO V8 algorithm, it is actually a latest implementation by the Ultralytics library, where the V8 version is faster than the pre-existing models by 120%. And we also compare this YOLO V8 with cataract detection algorithms like Inception V3, VGGNet, AlexNet, ResNet 50. And notably, YOLO V8 surpassed both algorithms in the terms of accuracy and speed. So the key advantages of using YOLO V8 algorithm are its high accuracy, where the YOLO V8 algorithm achieved a 95% accuracy in this cataract dataset, which surpasses the VGG19 and ResNet 50. So the second one is that the fast processing. YOLO V8 stands out as an efficient algorithm, making it well suited for real-time applications. And the third one is that it is cost effective, being free and open source. YOLO V8 offers affordability in its utilization and possible applications of cataract detection using the YOLO V8 algorithm. So coming to the module description, for the first step includes data collection, where we collected data from different existing data sets, which includes cataract, and the images are sourced from a variety of settings in different light settings, and including medical institutions, hospitals, and online repositories. So the second step is the processing of data. So the pre-processing of data includes two steps, where the first step was we separately labeled every image using with the help of bounding boxes, and the second one is that every image was resized to a size of 640 by 640 pixels, as the algorithm expects the input images to be in the same size. So coming to the third step, splitting the data. So we split the data into three different sets, which includes 70 percentage, which we use for training, which includes 711 images. So 20% for validation, which is 203 images, and 101 images for testing, which is 10 percentage. So coming to the training of the model, training in a deep learning is the process of feeding a deep learning model with data and allowing it to learn from the data. So the model will adjust its parameters in order to minimize the loss on training data. So once the model is trained, it is used to detect cataracts. So while training, we trained the particular model for 50 epochs, where we got the best results and improved accuracy. So talking about the validation, validation in a deep learning model is used for fine tuning the model and detecting errors, and to adjust and alter the model. We used 203 images for validation, which is 20% of the data set we have used. And coming to the testing of the model, to evaluate the performance of our model, we use this test data set, where the training data where the model uses the training data set to give the inference and output for the test data set. So this is the data flow diagram. So the first step is collection of images from different data sets, and the second step is that pre-processing of images, where we use bounding boxes to classify the images as cataract or normal, and resizing the images to particular pixels. The third step is that splitting the data into three different sections, which are training, testing, and validation. And the fourth step is that building the YOLO model, which we have done for 50, which where we trained the model for 50 epochs. And the fifth step is that testing the model using the data set, which was never used before. So the model would have never seen any of the images which were used for the testing data set. So the results are accurate. And the final step is that implementing the model. So this is the architecture diagram. So here we can see that the image of the eye is captured through live feed, and that image of the eye is given to the cataract detection model, where the cataract detection model detects whether the particular image has cataract in the eye, or whether it is a normal eye. And the results are shown in real time to the user in the form of bounding boxes around the image of the eye. Um, so these are the results which we achieved for different epochs. So we can see that after 50 epoch, after training the model for 50 epochs, we got the precision of 95% and a recall value of 97% and a mean average precision of 97.5%. So this is the accuracy which we have come with by comparing with the other models like AlexNet, VGGNet, ResNet, and Inception V3. So our model shows a value of 95%, even though models like Inception V3 have a higher accuracy of 98.9%. They have the disadvantage where cataract cannot be detected in real time, where in the pre-existing models we have to like capture the image of the eye and upload it to the model, where the model takes time to recognize the image of the eye and produce the results, whereas the YOLO V8 algorithm can do it in real time, and it is actually the fastest method. So this is the confusion matrix where the cataract, where the model detects cataract, where the in the presence of cataract, which is 97%, and it detects normal eye, which is 99%, and the background is 100%.
Sir, you left 1 minute for the presentation. Kindly conclude.
Okay, sir. Okay, sir. So as you can see, this is the final output where the left image shows the input image of the naked eye, and after uploading this image, we got the output in the right in the form of a bounding box where the particular model is 75% sure that this is the image of the normal eye. And in this image, the left image shows the input given to the cataract model, and the image in the right shows that the model is 80% sure that this is the image of a cataract eye. So coming to the conclusion, high accuracy, low cost, and quick turnaround times defines this system. So by utilizing this deep learning model, the system achieves an impressive accuracy of 95% in distinguishing cataract eye from the normal eye. And evaluated on a test set of images, the YOLO V8 performs very well. And with high accuracy, precision, recall, and mean average precisions demonstrated by the model, ophthalmologists can identify cataract diseases earlier and more accurately. Thank you.
Thank you, sir. Kirit, sir, any questions? I think the sir has no questions. So let's move forward for the next presentation. I would like to call Sunil Kumar for the paper title Enhanced Flood Forecasting Revolutionizing Prediction with Federal Learning. Is anyone here from his team? Okay. Next, Chandan Kumar for the paper title Forecasting Political Security Threats, a fusion of Lexon based and ML approaches. Is anyone from his team is present? Okay. So now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for support during the 8th version and the previous 7 version of the conference. We'll be happy to see you in the 9th version in 2025. We will all the presenters will be getting their digital certificates through email within 2 working days. Further, all the paper have already forwarded to the Springer. The publication will be live in 6 months. Kindly cooperate with the team of SMARTCOM 2024. I also thank our session chair, Dr. Kirit J. Modi, for chairing the session. This is the token of appreciation to the chair on behalf of the team SmartCom 2024 and Global Knowledge Research Foundation and partners. Sir, we would love to hear the word of wisdom. Thank you, sir, for your valuable presence. I kindly request all of you to turn on your cameras for a quick snapshot of the virtual conference. I request everyone to kindly turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe, stay connected.